Hello, and welcome to a video about momentum for grade 12 physics. Now, momentum is a property that any moving object has, or any moving object with mass has. Anytime that you are moving with a velocity and you have a mass, you have momentum. Momentum is important for us because momentum can be used to figure out what happens before and after collisions, because we know that momentum is always conserved whenever you have a collision. Let's look at this in a little bit of detail here and see what's going on. So the first thing is, remember, momentum has a formula, P equals mv. So this is our formula for momentum. P is the symbol for momentum. Why is that the symbol for momentum? Because m was already taken. I don't actually know why that's the symbol. M here is our mass. And remember, that's in kilograms. And V is our velocity in meters per second. So this is the momentum formula. We can easily find how much momentum something has using this formula. Our units for momentum are a little different, and they're kind of a strange unit, but it comes directly from these here. So the units for momentum are kilograms times meters per second. Literally just combining those two units. You can end up with different units for momentum, but these are the standard ones that we're going to use. Now, one of the things that's really important for us is remembering that momentum is conserved. Momentum is conserved. And this is a really important concept. Like energy is conserved, energy is always conserved in terms of kinetic energy and potential energy. Of energy before and after have to be the same. Momentum is conserved in the same manner. So if I have momentum before a collision, my total momentum must be the same after a collision. So what this means is that if I go before, say I have two objects that are going to collide, I can figure out the momentum of these. So the momentum of that and the momentum of that, if I add those together after the collision, so let's say that the square ends up going that way and then the circle ends up going that way slowly, the total momentum here needs to equal that. So whatever happens before and after the collision, my total momentum before must equal my total momentum after. Now note, momentum here has velocity in it. Velocity is a vector quantity, which means that the direction matters. Because velocity is a vector, momentum is also a vector. So my momentum being a vector means that negative momentum, or momentum to one direction, is different than momentum towards the other direction. So if I have negative momentum, so say my momentum in that direction is negative, and the momentum in this direction is positive, those are different. I have to be careful with my magnitude and my direction because it is a vector quantity. This also means that I can do vector collisions in 2 dimensions or 3 dimensions, and I have to do all of the vector math with that to figure out where I'm going, where my objects are going, and that sort of stuff. This is really useful if you're trying to simulate a collision. For example, in a video game, how does a physics engine work? Well, it works by simulating these collisions and using the principle of conservation of momentum, using all the masses and that sort of stuff. That's really useful. Let's take a look here at an example on how this works out. In this case, I have a 42,000 kilogram train car. So there's a mass traveling at 10 meters per second. There's another velocity towards another train car. Okay. After the two cars collide, they couple together and move along at 6 meters per second. So I got another velocity there. What is the mass of the second train car? So I'm asking for a mass here. So, the way that I can figure this out, I'm going to draw this out here. So what I've got is I've got a train car, and I'm going to say that's number 1. And it's moving towards train car number 2 at 10 meters per second. This is great. It does not say anything about the velocity of the second train car, so I'm going to assume that my velocity here is 0. Now I can figure out, I know my mass here, and I can figure out my total momentum. So writing things down, if I've got mass of the first train car is 42,000 kilograms, velocity of the first train car is 10 meters per second. Mass of the second train car, we don't know. Velocity of the second train car, in this case here, before the collision, is 0 meters per second. What's my total momentum here? Well, I don't need to figure out this one. So I'm going to make myself a note here. Total momentum is 0 for car 2. So the momentum, I should actually cross that out. The momentum for the second car is 0 because the velocity is 0. So I don't need to figure that out to find my total momentum. I just need to figure out the momentum of the first car here. So in this case, my momentum is the mass times the velocity, which works out to 42,000 times 10. And that works out to 420,000 kilogram meters per second. So this here is my total momentum before the collision. It's a total momentum before the collision, gives me my velocity, or it gives me this here. Now, I need to figure out after. So this is before. Now I need to do after. I know that my momentum here is going to be the same after. So I can say my total momentum after is 420,000. And I can just transfer that over because momentum's conserved. In this case, I now know that my velocity is 6 meters per second, and I'm looking for a mass. Now, what's going on here? Well, after the collision, so before the collision, I have car 1 moving towards car 2. After the collision, I have them stuck together. So I have car 1 and car 2 that are latched together here. The coupler latched together, and these two train cars are locked together. So car 1 and car 2 are locked together, and they are both moving that direction at 6 meters per second. So I can treat this as one object with a large mass and a velocity of 6 meters per second. So here, I can just use P equals mv. 420,000 equals my, now notice this is my total mass, times my velocity, which is 6. So the total mass of both cars combined together works out to 70,000 kilograms. That's my total mass there. What's my mass of car 2? Well, I'm going to take 70,000 minus the 42,000 of car 1, which works out to 28,000 kilograms. And there's my final. So this mass here is for mass of both cars. The mass of the both cars there is 70,000, and I'm subtract mass of the first car there. This becomes the mass of the second car. Okay, when we're talking about momentum, this is a fairly common question where I've got a total momentum before, a total momentum after. And in this case, I've only got two objects here, but they combine, so my total mass is the same after. They might not combine. There might be a bunch of different scenarios and situations, but this here's a fairly common type of problem where I need to move my momentum, figure out before and after, and go from there. Often these are helpful to diagram out and sort of write out all of the things in there, but this is, again, a common momentum question. So I hope this has been helpful. If you have any questions, let me know, and I'll see you in the next video.